Hello guys, welcome to this channel. In this video we will solve GFG's problem of the day. Today we have given a tree, root of the tree. We have to replace each node contain the sum of all the nodes greater than that node. So for 11 it will be the what are the values which is greater than 11. So we have the entire right subtree, right? We have to replace the sum of all these nodes with the 11. For 40 there is no node, so replace it with 0. For 35 here we have only 40, so we have to replace it with 40. So how to solve this problem? It can be solved in two ways. One is using recursion and other one is using recursion plus prefix sum plus binary search. So first of all I will go with the second option, and I will again optimize that solution using recursion. So the first approach will be, first of all we will traverse this array in order manner, and we will store all the values inside an array. So basically it will be in ascending order. In pre-order the values will be in ascending order. So 1 to 7, plates 11 and 15, 29, 35 and 40. Then we will maintain another array, prefix array. So here the 0 and 35 will be here 40 plus 40 plus 35, that is 75. Using these two sum, that will be 104, and again we have to maintain this lengthy array. And how to replace this node value with the sum of all values means, for 35 using binary search we will find 35. Here we got this index value, and which corresponding to that index we have 40. We will replace 35 with 40. Similarly for 29, so for 29 it will be 75. We will replace 29 with 75. So for this case, first of all the time complexity and space complexity will be, first of all we have to traverse this one. So big of n, where n is the total nodes, right? We have to visit every one. Or big of h for traversing, and for here it will be, we have to traverse again and maintain one other prefix array. So space or complexity will be big of h plus big of n for this array, and again we are maintaining one array, and again big of h, since we have to again traverse that array and change the value. Space time complexity will be, first of all big of n h plus traversing one more time in this array big of n, and then for each node, so it will be big of h into log n. For each node we will perform a binary search and we will return that one. So this is the one of the moderate time complexity problem. Is there any solution which is optimal than this one? Yes, using recursion we can optimize this one. We can neglect these two arrays, and using a single recursion we can replace all the values. So I will explain how to do that one. See, for 11 we have to get the sum of the right subtree. For 29 we have to get the sum of its right subtree. For 40 we have to get the sum of its right subtree. Since there is nothing, it will return the 0. For 2 it will be tricky, right? For 2 we need this entire value and this value. Using a recursion call we can get this one, but how can we are able to access this one? See, before making this call only, we will make this call and we will add this value, and we will pass this to this thing, this to here, and For each value we will get that previous sum, so the upper sum plus this right part. So basically see, it will little bit confusing, but it is easy only. First of all, before solving this one, we have to first solve this array. So first of all, we have right, we have data, and we have left. So basically we can access these three only. First of all, we have to make a right call. We have to make a right call. Then what we have to pass in that array? Sum only. Why? Because sum means all the node values. So here we have to pass some data, right? So that is sum. For right call, we will pass this sum here. And what about the data? For 11, what we have for 11, first of all we have to replace it with this sum. That means right plus let us solve for 2. For 2, first of all, what we have to do? We have to first get the right. So right plus sum. Sum means all the values. We will pass the sum to the right side and we will get the right information here. So data will be sum plus right. And what about the left? For the left, we have to pass this data here, this data here. We have to pass the sum. Sum means this entire sum. From 11 to 35, we have to pass that sum plus this right node and this current value. I will explain one more time. See, to get 11, we will solve this entire subtree and we will return this entire sum here. So basically, what again we have to pass some parameters. That parameter will be the sum. Since for 7 we need this entire sum, right? So that's why we have to make some variable and we have to pass that sum to each and every node. So by default the sum will be 0 and that sum will be updated while we are making the recursion calls. Why recursion means, see, for every tree there are subtrees, and first of all we will solve that subtrees and we will eventually complete this entire tree. So let us go and understand it better. So the return type will be the int. Why? Because we have to return the entire sum, right? For 2 for 11 we have to return this entire sum. So that's why the return type is int, and then solve non-root and int sum. Sum means this sum, entire sum. We will call this one. We will call that function root comma sum will be the 0. Initially it will be 0 because there are no upper levels, so that's why the sum is 0. And the base case, if root equal to none, then we will return 0 if there is no root. So let us see. Imagine we are at 40. To solve the 40, what we have to do? We have to make the right call and we have to pass that sum. The right call will give 0 and sum is also 0. So here first of all we have to calculate the sum here using right. So int right will be solve of root dot right sum. I already told you this sum. So see, for 2 it will be right call, so that we have to pass this sum to here. So that's why I am passing that sum here, and then after this write, we have to modify its value. So node dot data will be sum plus data, sum plus write. This enter sum plus this write sum. So for 2, this will be enter sum plus write sum. Enter sum plus write sum. Enter sum plus write sum. Now sum plus write. Similarly, we have to also make another call to the left subtree. Then what we have to pass in the left subtree? For 29, what we have to pass? We have to pass this sum. Okay, let us see. 2 is the left child of 11, right? For 2, what we have to pass? We have to pass this entire sum. This entire sum. For 11, it will be the right. Plus root dot data. Plus we have to pass the root dot data. Since it is already modified, we will store the data here. Write plus root dot data. Solve write, this write plus root dot data. For 2, this entire sum. See, if you are at 2, we have to pass this 2 to here, this 7 to here, and this sum, this upper sum to left. We have to return the data, right? Then the data will be, see, for 11, what we have to pass? See, for 11, to get the data for at 11, first of all we have to solve this 29. For 29, what we have to do? We have to return the data. We have to return this 29. We have to return this right subtree, and we have to return this left subtree. I think this is the code, right? And so we are passing the sum here, and we are storing the data here, sum plus right, and again sum plus root dot left plus right plus data plus current sum, and we are returning left right data. Let's compile this one, checking for any other errors are there or not. So node dot data cannot files. Okay, it's not node. Line number 18. It will be root. It would be root. Yeah, test case passed and submit. Yeah, 100% accuracy. So thank you guys for watching this video.